Okay, I'm not the kind of guy who normally wakes up and throws on some spandex, but when given the chance to see how one of the fastest, lightest road bikes is engineered and manufactured, I'm willing to go the extra mile. This is the Madone. It's considered one of the most advanced bicycles ever made. First constructed in 2003, it's won multiple Tour de France races and is Lance Armstrong's bike of choice. But engineers continue to refine this revolutionary machine, making it even lighter and faster. And with their latest model,
they didn't just improve on a previous design, they completely broke the mold.
To find out how, I've come to Trek Bikes in Waterloo, Wisconsin. And let me tell you, it took a whole lot of sweet talking to even get into this facility. Trek heavily guards the engineering secrets that go into this bike. So this is the state-of-the-art greatest bike ever built? Is that what we're looking at here?
As of today, this is the best bike that we've got.
What gives a road bike like the Madone its edge? It all starts with the frame. Everything else is secondary. This is the material that revolutionized the modern road bike: carbon fiber. The engineers at Trek were among the first to manufacture a bike's entire frame and fork using this lightweight, super strong material. It's the same stuff that's used to build stealth bombers. Each sheet is only 5/1000ths of an inch thick, as thin as a dollar bill. But notice that the grain of the fibers is unidirectional. When workers at Trek's molding area layer these sheets on top of each other, the fiber patterns crisscross, giving the finished piece its strength.
This is going this way, and this is going this way.
Right.
So this is like a 10-layer stack or something.
All of our ply stacks are different thicknesses. In certain areas of the frame, we only may have 4 to 5 plies of material. In other areas that require greater strength, we may have upwards of 40 plies of material.
And that's just saving weight as you go across the different parts of the frame.
Absolutely.
Standard bike frames have long been made of steel, which is heavy and slower, or aluminum, which is lighter but less durable. But the Madone's carbon fiber frame makes it stronger than steel, yet as light as plastic. And the lighter the bike, the faster it goes. This thing is so light.
We make a couple of different versions, and this one weighs about 1,000 grams, which is 2.2 pounds. And the incredible thing, Marshall, is this is actually the heavy frame. The neat thing about this is that a water bottle weighs more than the frame does. So when you put the water bottle in, you've doubled the weight of your frame.
Oh, jeez. Finding a way to make the newest Madone even lighter was only one of the challenges facing Trek engineers. They also wanted to make it sturdier and more comfortable. For months, they reevaluated everything about the Madone's frame: the size of the top tube and down tube, the design of the front fork and bottom bracket, and the position of the seat post. You might not notice the innovations, but they definitely have an impact on the way this bike performs. Once the carbon fiber sheets have been layered, this carbon cutting machine then cuts them into shapes. The workers take these shapes, known as preforms, and assemble them into a series of pieces called a kit. Each kit will become one section of the frame.
This is going to be a fork.
20 different pieces to make one fork.
Yes.
The molding operator then places the preforms in the casting die. This is where the carbon fiber sheets become three-dimensional parts of the frame.
Now you can see that she is working the material down into the mold to form the shape. The preform is designed to fit almost perfectly into the mold as she does this.
Some of the carbon fiber preforms are laid on top of each other. That adds extra strength to vulnerable parts of the bike, such as the fork, while leaving other areas, such as the seat mast, more flexible. Flexibility and strength are key when you're riding 100 or so miles in a day.
Again, you can see the directional nature of the carbon fiber, but she's only putting it in one portion of it, so we can build up thicker layers in places that require more strength or stiffness and fewer layers in areas that don't.
After the operator fits all the shapes into the mold, a molding press squeezes the two halves together and heats them. We were forbidden to shoot this stage of the process. That's because the precise combination of heat and pressure that forms the carbon fiber parts is one of Trek's most guarded trade secrets.
When it is all done coming out of the press, this is actually the finished part that is actually formed. From flexible, pliable material to a stiff head lug.
That's unbelievable.